So maybe you'll mask out this and this one. In trading it, you'll mask it out so that you obviously get something similar to this. But now whatever values you get here, you're going to compare this with this. This helps tell you. So this one gets now compared directly with this, and this one gets compared with this. This one obviously, if this was a NAND, obviously I can't be comparing this, right? But the ones which I did, which you did have the values for, right? You're comparing only those.
So how do we fill the missing shit?
No, the missing stuff is being filled by itself. But you know, see, the missing part can't be compared, right? You can only test the values which you already had. You already split it. So either 80-20 rule or 75-25, you already only train the model on 75% of the data or 80% of the data, right? The remaining 20% is going to be used now to compare your final predictions to the original values. That is how you're going to do the comparison. Because if you try to compare it to the null or the missing value, how can you compare it? You didn't know those values exist or not. You don't do it on the missing values. It's on the 20% or the 25% existing data, which you now consider as your test. That part is what you're going to check the RMSE for.
So how do you impute? Sorry, I recorded myself. But how do you impute the missing?
You don't impute anything.
No, I mean like you're trying to create like the things that are missing. You're trying to predict something for it, right?
Yes. How does it do it?
Yeah.
You create these matrices, right? The objective of this entire approach is not to get that one matrix, but to get these two matrices. Through this, you end up getting that thing there. When you multiply these, right? How do you? The thing is, you are now deriving out of almost thin air these random values or these random matrices.
When you see random values, it's not you plug in something from negative infinity to infinity. It's random based on.
You can just say zero. Everything is zero itself.
Oh, as in then you keep
Updating and alternating each of these values constantly because.
Based on what is
So the multiplication of this with this.
But it's an infinite number of permutations and combinations.
No. So this is like how when we start out with, you're right, it's almost an infinite number, but now when you're trying to actually understand what's the error which is there, so when you multiply that, you'll get a 1, right?
Yeah.
Actually, oh wait, so this is 2, this is 3. So it's 1 by 1 plus 2 by 3, that's 7, right? That's what this one first value is going to be, the cell. Now this 7 is compared to this value here, and you figure out what the error is at this point. The least squares part, right? Based on the overall error you've got right now, in each iteration, you're going to try and update each value here. Then you try to update the values there.
Right.
That's how it's happening. That's why it takes so much time to actually do this algorithm. Because you have to constantly keep updating the weights, the values across both the data sets. Constantly meaning alternatingly, but iteratively you have to update it. So I'm actually trying to see whether I can run my myself. Hi, just a quick question. How many people have not submitted the feedback? Sorry. You'll have to submit the feedback, please. Take 5 minutes if you want, but submit that feedback. That's kind of crucial. I need feedback. Basically, the mid-course survey, I think everyone's gotten it. So whoever's not completed it, please just check out. Right. I'm trying to see and showcase the all. So, I mean, this is, I believe, at least this is what I've remembered as. I mean, this is the kind of result which, one of the ways I've gotten the results, one of the formats. So for each of these users, these products, this is the rating that, I mean, I call it rating, but basically it's the score, the preference, which I got. And out of the total sum, I mean, that's another metric. Basically, this is the final preference, the normalized preference. So for this user, for this product, it's saying 0.25, so on and forth. Right? This is the overall matrix, which is going to be calculated and given. Right now, it's coming in as JSON. I mean, each line is a JSON or a separate row. Right? That's all there is. All right. I'm trying to find if I can give you. Sorry? Yeah.
You mentioned that you'll always be starting at the original matrix will be as fast, usually as fast matrix. And we do it when we even populate 10% of the cells.
It can be. Sorry.
If we could even be populating about 10% of the cells in this matrix.
You can use it.
So when it comes to training test split, maybe working with very, very small,
Yes.
and that will
That's still gonna be fine.
that'll be fine.
Because I mean, think of it like this: you've got, I mean, it's saying out of 1 billion ratings,
Yeah.
you've got 10% ratings. That means that's like what, 100 million? Out of 100 million, if you got to do of course, 10 million, 100 million is also a lot, right?
Right.
It's not easy getting the 100 million customer data points, right? Even if you got a few million in this case, what, 2 million suppose, right? I'm saying that split it up, I say 75-25. That means you've got 1.5 million points on which you're training your model, and 500,000 points almost. Actually, even half is too much in this case now. You probably do 80-20 at least. Train it on 1.6 million, on 0.4 million, test it out and see what the results are.
But 10% of
The 10%, so basically I'm saying that out of all the 1 billion cells which you had, right, suppose, you ended up having only 2 million points, which you had as input, right? That 2 million represents actually 2%. No, 0.2%. 1 upon 1,000, right?
Yeah.
So 0.2% also, if it's there, it's fine. Suppose. In this case, out of the 2 billion ratings also, I'm saying split it up now, train and test. So out of the 2 million, if you've done 80-20 split, 80% of 2 million is 1.6. So you train it on 1.6 million engagement points, and 400,000 points are considered as the test set on which you're going to evaluate the RMSE. Any 400,000, it can be randomly selected, that's the objective. Don't take it in any particular manner.
Right. I mean, in terms of absolute numbers, that sounds like a lot, but you mentioned that there's supposed to be a
Billion.
specific ratio as well.
So you want at least like around,
Your
I think it's either
features.
0.05 or 0.5, one of the two.
Data point.
The sparsity, basically how sparse your matrix can be, either 0.05 or 0.5 or something like that. Again, you can Google that up again and figure that out. I believe it's 0.05. Yeah, 0.5 even in this case becomes a lot, right? Right, so this is, I mean, an example. Obviously, no screenshots, please, on this one. The objective is, we were using product descriptions along with user behavior. So this is saying that this was the original reward that we're looking into. So which are the top 14 products similar to item number 363, right? So this is the actual, we used 3 basic things at least initially. The name, the description, and the terms and conditions. So you can see it's like pure HTML which comes in, right? Use this alongside the number of users who are purchasing it, so on and forth. For this product, which is saying 350 ringgits for 1 year membership, it's saying the similarity score which it finally got the most highest one was something which is saying get 1 year membership for 350 units. Pretty similar, but the objective is a different product altogether. Okay, right? More importantly, then that's when it started going into other things like complementary scalp therapy for around 650 ringgits. The discount again. So the thing is now it's all for spas. It's automatically tried to pick it up, and it's saying how do you know that? I mean, it's trying to say that it's all health or spa related products. These are the ones which are most similar to the original thing you started out from. It may not sound very appealing as of yet, but when you start thinking of 40 million users against more than a few thousand products, which can be things like literally across the place because it was e-com, right? So things like, well, in this case it's spas. There was F&B, there was bubble tea, there was, you name the thing, like digital gadgets as well. Given that kind of a concept, if it's still being able to tell you related to which feature, I mean, which particular part is it looking into, you can see that it's performing at least somewhat well. Of course, it's performing horrible once you see the similarity score starts dropping. Say, handcrafted beverages, kitchens, so on and forth, right? But the reason why it's trying to do that is simply that if you notice, this is where we were actually combining things like the description alongside the price, discount, so on and forth. So the discount which you're actually getting out there, right? We try to prioritize and work with that concept. That is one of the main factors. So the discount that you keep getting, that's why it seems to say it's like a pretty highly discounted set of products, so on and forth. It's going with that. I think I still see only 15 people who've given feedback. Sorry. Anyone who's not given feedback?
Doing now.
Oh, okay. That's one person. But still like 6 more people. Shauna might not be there. Oh, okay. Okay, so I mean, these are just some examples again of how the results can turn out to be. This is how the raw results can be, first of all. Just trying to help show you all. This is the raw set of results which can come out. Based on this further, these are the top end results which can be pushed out. I mean, this is just some random sample that I right now pulled out, so it doesn't seem to be making sense. But again, when we actually started looking at, I mean, this is one of the earlier ones. I can't find the entire folder right now for some reason. But basically, when we started actually segmenting them by the industry first, right? And then we started looking at similar products across them. It started giving far better results. Here, again, like we can see, if it's actually trying to go across multiple segments and then you look like that, right? It starts going across the place. It's starting from a spa, then it's again going to like scalp therapy, and then it moves on to F&B, so on and forth. A lot of different factors across the place. When we actually started segmenting it by industry or category, and then we worked on it, it gave much more relevant results. I'll try to find and showcase if I can. Any questions till now on this part? Oops. Any questions? If you're going to start going through, I mean, the content which is there as well, right? You'll get an idea. Oh, okay, we actually skipped the content. My bad. So maybe that's why we can actually move back into the, not this part, but the actual code. So there's a file called as startercode.ipynb. So the first thing that we probably want to be doing is, there are two data sets, actually there are multiple data sets for you all to even go in and play with now. Yeah, ML latest small. So you've got movies.csv, you've got ratings.csv, and you've got others. So I'll go back into this as well, but just, sorry, a last few minutes thing. I think there are two people who are still left for the feedback, sorry. Is it? Whoever it is, you know who you are. So can you just try and like send it over in a while? Because they need to be tabulating some things later. Thanks. But do try. Sorry? No, I included Shauna as well because we've got 19 people right now. If you can tell Shauna, if she's, but if she, I think she's sick. She can send it later as well, but the others, whoever the two people are, please try and do it.
Isn't it like the question like, many people never press send survey and just to submit. It's not about doing or not doing, it's about pressing send or not send, right? You get me?
In the,
like, do they successfully send the thing? How do you know like they send the thing?
I don't know, I mean, Aurelia was telling me that how many people have submitted or not.
Oh,
I mean, have you submitted it?
yeah, sorry, everybody has submitted it, but they do not know whether they have pressed the button or didn't press the button, right? You get what I mean? They probably do something then they assume that they submit, then they never submit. You get what I mean? Oh, something cocked up.
Okay, so just try it again. I mean, if you've not submitted already.
If you submit already, it will just, they won't let you submit again.
Yeah.
There'll be an incomplete.
Yes, maybe actually you can just take a few minutes everyone just check if it's still there. Don't worry, we won't eat you, but just try and finish it. Simply because I think earlier needs to get that done. Hey, we got it. Thank you. So, this part out here is pretty much talking about using the movie lens data, right, for going ahead and doing the implementation. Mind you, the one out here is not that complex or not the real, I think, ALS distribution, thing that we have. let me show the basic version that we have. So we start with obviously reading in the CSV. So you just read in the dataset movies first, followed by reading the dataset called as ratings. So basically you have one dataset which refers to what's the movie ID, the title, and the genre, right? And the other is talking about the user ID, the movie ID, and the rating that they got. But more importantly, also the timestamp on which you got it. It's just the data set which is there, you can play around with it. We're just going to do the initial part first. So currently it's saying you don't need the timestamp column from ratings, okay? But theoretically, do you think you need it? Why?
It's like a time you have to consternize you have to make the time constant. Because like, I mean, people's ratings go up and down. I mean, at first be very good and like, it's kind of
Right,
And
so
it's
basically you can
different.
bias it completely in the sense that initially it may be a very hot, it may be a decent movie, but then word of mouth kind of elevates the entire thing and then it can become like a cult movie, but maybe you don't like it as such. But so you've got to actually start considering the fact that time actually can play a major role, but since we're just getting started with it, we want to drop it off. The objective is first to just do something simple enough, right? Always start with doing something which is simple. Get the first results and then you move in the advanced version. Don't try to go for the moon immediately. But keep in mind you've got to go to the moon. So basically we're dropping timestamp from ratings and from movies. So movies also has genre, right? Right? Technically, can you try and determine or do content filtering on this? Look at the way movies is actually structured. A movie can be multiple genres, right? So can we break it up into multiple different features of genres? Possible, right? So the reason why I'm mentioning it is because, see, we may not be doing too many things right now with this given data set. But if you do have the time and you get a chance, think of how else you don't have to do everything at the same time. You have to just keep in mind that there are different ways and approaches which you can implement. You have to start recognizing what is possible, what is not possible. Right, so it should work, alright? Now once that has been done, basically we're being asked to merge the two data sets. Why do you think they asked me to merge it? Hold on. Does anyone remember how to do the merge? You have a merge function, right? pd.merge, whichever data set you want, the two data sets you want. You can actually specify how do you want to merge them and on what you want to merge them, right? By default, you will always be doing the inner merge itself. So once you merge it, so we can see that, I mean, originally the ratings has 100,000 and 836 rows, right? And movies on the other hand is only 9,742. After merging, you end up with 100,836. But that's like, why do you think that's the case? Technically, movies has less, right? After merging, why do you get different shapes? I mean, why did you get 100,000? You did an inner join, right? Meaning only those elements which are common should be there. So if it's gone to 100,000, what can that maybe mean? All those 100,000 rows which are there, the movie IDs, all those values are present inside the 9,742, right? The reason why I'm mentioning and telling you all this is simply that you have to confirm and ensure once you do things like merges and joins, right? The dataset shape actually matches to what you're expecting. Why? Because sometimes this can lead to a lot of problems. You may have extra columns and you have extra rows in your thinking, or lesser number of rows. You have to be clear what you're looking, why you're doing something. So basically, to get this matrix right of right now, what we're trying to do is item-based collaborative recommendation, not user item, but item-based collaborative recommendation. So in this case, the title is going to be the index, the user ID will be the column number, and the rating is going to be the value. Okay, so the reason why we did the merge is because now we have, you have the user, you have the movie, and you have the rating for that movie. Alright? Although technically you could have done, I mean, or gotten the category code from this column, or gotten a number for this column. Since you already have the movie ID, you want to be using this together, the rating for it. Okay? So from this table, if you create a pivot table itself, do you think it can do the job? Basically, you want a table where the title or the movie ID is going to be the rows. The columns are going to be the user ID, and the rating is going to be the values. So pivot table can actually help you with this, right? And that's pretty much what we're going to be doing right now then. So pd.pivot table can actually help you with this. You can specify what the data set is, the complete data set. Now after you do that, you can tell what's the index specifically that you're wanting from this. Which field do you want as the columns? And what are the final values that you're looking at? Wow. So this is what is also called as a sparse matrix, right? Where you have far more nands than you have even anything else, right? And in case you want to actually pick up, what's the size of this matrix? Pivot movie dot shape 9,000. So now if you notice, what's happened is, although originally from this data set DF, there were 100,836 rows, right? You now have only 9,719 rows. Because these are the unique number of movies or titles which exist in your entire data set, and only 610 users. Okay? That's the reason. Now, if you actually want to be creating a sparse matrix, right? This is how you would go about doing it, because the entire data set that you have right now, it's such a big one, you don't need that much empty space going waste. Before we do that, can you actually calculate and say, how much is the sparsity of that data set? So these are the total number of null values which exist in this entire data set. Alright? So if you now divide this by df.shape, into yes, that's the point. So it's saying, at least as of right now, for some reason, that it's only 14% is null values. Basically, it's saying that around 75% is filled right now. But that's also because this particular data set has been created actually for us to work with, right? So when we're talking about cosine similarity, right? Actually, sklearn has a simple, since we're looking at item-based collaborative filtering, right? sklearn actually has something which is called as pairwise distance.
Given the number of columns, you just take 99719 times 610.
Yeah.
I'm getting 98%.
Why is it that I'm not getting it? When you did this?
I just took the line of code above then over 9719 times 610.
This multiplied by?
Divided by 9719 times 610. Is that right?
Oh, it's 90% because 98% is empty.
Yeah.
It shouldn't be over the
It's just too high. 40%.
pivot movie rather than the
Sorry?
You're trying to find within the movie, right? So you want to find the missing values within the movie. You shouldn't be using df.shape. Multiply by.
Oh, okay.
Shape.
Okay.
Multiply by it.
Yeah.
No, as in, we shouldn't be using df at all here. We should be using pivot movie for everything. So your original formula should be accurate. It's accurate, just replace df dot shape with pivot movie dot shape. Because you're trying to find the shape, the number of mouse within
So
pivot
pivot maybe not. What are you saying? Which one?
So your original
Pivot.
your original formula, pivot null is null sum
Mm-hmm.
divided by pivot movie dot shape index 0 multiplied by pivot movie shape index 1. Then I get 90%. I get 98% now.
Yeah, 98.2.
This divided by pivot movie dot shape 0
Yeah.
times pivot movie dot.
Shape but as in, you have to something like.
Right.
Yeah.
And that's That's what my concern is. Why is it?
Multiply, right? Not n.
Ah. Not multiply, actually.
It's not divide. I think one more, yeah. Yeah.
I had quite literally done that when I did that earlier, I thought.
No,
Yeah,
because just now
you
you
use
use
dn, not even v.
You use the wrong data frame.
My bad. So basically it's saying that it's like 98% sparse, right? 98.29% sparse, which means that you've got only 1 point something data, percent of your actual data set coming in. So that's where actually you would be looking at converting it into a sparse matrix itself. Sparse pivot, sparse the CSR. So this is, I mean, an example. So once you convert it as sparse pivot, right? All you have to do is parse the CSR matrix, and you give it the actual data set you're looking into, right? Once you've done that, when you just print out the sparse pivot, this is quite literally what the computer is seeing as well. For user number 0, this is the item number 609, and this is the rating that you have. Okay? The reason you want to do that is now you're actually representing only that 1.7% of the data rather than storing 98%. Despite having a more complex index. Because here you've got a tuple or combination of two values, right? Sorry. It's still a better way of doing it. Right? So now in order to actually calculate the cosine similarity, because we're looking at item-wise recommendation, right? What we can be doing is you can just use sklearn dot pairwise distance. You give it this sparse pivot, and you specify what are the metrics. So when you do this, right, you'll realize that, I mean, when you go to the documentation for this metrics, sparse pairwise distance, right, this is the way that it's actually been defined as. What is the x-axis? I mean, what's the data set we're giving it if y equals none? Specifically, Euclidean is the default distance you're looking into. Do you want to parallelize it or not? Why am I showing this right now to you? You can actually choose which metric do you want. Cosine, Euclidean, L1 regular, I mean L1 distance, L2, Manhattan, and others. As long as it's a distance metric within sklearn.metrics, you can pick it up. Right? So right now what we're doing is you're going to be using cosine because that's the one which makes sense in this situation. And there you go. You already have the results which are coming in. So in order to actually since we were looking, what are we trying to figure out right now, by the way? What's the original question we're trying to solve? Anyone? What is it? Which type of, what are we trying to understand? Similarity between?
Similarity between users.
Title or the movie itself. To understand the similarity between the users, we're creating item-based collaborative recommender. So that's why you've taken out here in the data frame, right? After you've done the metric, the pairwise distance, your columns are the index, which is your title, right? And now you can just do right, there you go. So you can actually determine that for each movie, which are the relevant or similar movies, right? Okay.
Could you scroll up?
Sure. Sure. Make sense? So what have we ended up doing right now, till now? What is this final matrix right now done? It's got the item based, it's got the similarity across the items, right? But that's all that it's been able to do. Please keep that in mind. After doing all this also, you've only got the output, not the results or not the answer to your original question. Which is that, which are the movies or the titles which would be similar to, if you're given a given movie, provided one movie name, find the top similar items. This is good, but it's useless until you can actually use it to answer something. So it doesn't end out here, okay? Just want to mention that part. So, is everyone done with this part? You all have taken on, how do we create the pairwise distance? So, the interesting thing is now actually evaluating and seeing how is it performing. Alright? So what we're going to be doing is, I slacked over the content, the code to y'all. It's a block rather than copying it, just copy paste this part. The objective is, say you're searching for Die Hard. Anyone not seen Die Hard? Yeah. You should start with Die Hard 4. Actually, fine. So for each title which is there, right, amongst all the movies, now you want to be printing out the movies which are most similar to it. So it says movies, we've got a recommended DF. Right. So remember we had two data sets initially, movies and ratings, right? So it's saying that from the entire movies data set which is there, first of all find that particular row which contains this title, right? Get this back, once you get this specific title, right? Use that to find out what's the average rating for this movie, the total number of ratings that you've ended up getting, and the 10 closest titles. How does that do that? From recommended DF, right? Given this title, this is recommended DF. The moment you do, you select this column and you do a sort values on that. You're picking up the first to the 11th value. Any idea why it says 1 to 11? Technically the first 4, first value should represent the highest figure, right? But why is it excluded the highest value possibly? 0. In this row, so when it's doing the sort values, is it ascending or is it descending? It's ascending, right? So it starts from the smallest value. now, I mean, if you look at it actually, it's, I mean, the 0 represents, it's inverted actually. The pairwise distance which is done. If it's closest, remember, we should have picked it up. Wait, hold on. Yeah, so it's saying a distance of 1 likely represents that it's the farthest away in this situation, and 0 is actually saying that it's the closest. Okay, so in this situation, when you've done a sort values, it's in the ascending order, which means the lowest values comes first. Each row, if you notice, it's got a 0.0 for which column? Against itself, right? Because it's going to be most correlated to itself. I mean, it's got the strongest relation with itself. So in that case, you don't want the highest value coming in. That's why we've done 1 to 11 rather than 0 to 10. Okay? Oh, it may not work exactly in yours either. So you're going to make it from pivot, just make it pivot movie, in case you're using the exact same thing. So it says that for Die Hard with a Vengeance, the first one, the average rating that it's got across all the users is now 3.555. But this rating is based on what actually others are saying, not what you're recommending. Okay? It's coming in from your pivot movie, which was the pivot of the original data set. Alright? So it's saying 144 people gave it a rating, and it's got a rating of approximately 3.5, so on and forth. And the 10 closest movies are movies like True Lies, Speed, Cliffhanger. Do you think it seems similar enough?
Not really.
Somewhat, but not exactly, right? Because like they're all action movies, if you notice. With, I mean, maybe not, definitely not, I guess, the Ace Ventura one as well. But the others actually tend to be a bit where there's some hero who's fighting against others, villains and bad guys, and there's action involved as well. So this is where it comes down to how do you actually evaluate all these concepts, right? You have to do a trait test split and look at the RMSE which can come in out there. But even from that, it may not give you very, I mean, how much can you believe it? So that's why you have to move either into a little bit more of manual validation, where you see the results for more than a few samples and you test it out, or you do A/B tests, which is you show the results to other users and you see what's their feedback like. One thing I'll just like to mention, so generally when we're doing recommenders, right, obviously you can't keep going through a few thousands or even a few tens of thousands of these, right, to validate it. One way, if you can convince your team to splurge a little bit of money, right, technically, you just need to understand how similar is it, right? But for that, in this case, you need to have domain knowledge. That's it. Do people know movies or do they not know movies? Right? If your audience who's going to be looking at it doesn't know movies, they're not going to understand too much. Right? So, one way of doing or resolving all these kind of problems, right, in terms of evaluation, is you can actually go to this platform called as Amazon Mechanical Turk, if you all have heard of it. So basically it's meant for distributed human processing, if you may. It's no more computing where you're distributing. What you're saying is, you'll give Amazon, say, a few cents to maybe tens of cents for each task that they do. And what they're going to do is, rather than distributing the evaluation to computers, they actually have a lot of humans who they pay money to. Quite literally. So it's that they're going to spread out the task across a lot of humans, and you can set the price that you want. That what is the price? Maybe it's a few cents, maybe it's 30, 40 cents, maybe up to $1, whatever. Up to you. You choose the price, you give the test to them, that given the movie Die Hard with a Vengeance, which one appears most similar? It's like a survey, if you may. Right? And you ask them to rate it or to give you feedback. Is it even relevant? Is it not relevant? Okay? This is also a way how companies can go about doing it. But the problem is then sometimes even convincing your team that, hey, you know what, let's spend a few $100 or depending how big your entire testing is, how do you go about it? And is it data which can be disclosed to the public as well? like this and got feedback on. You have to be careful. Just an example, I mean, how you can bypass the validation manually yourself. Because trust me, after some point your friends are going to stop answering your surveys. So you need to figure out ways how to do it. Alright. Any questions on this point? The collaborative filtering. User or item collaborative filtering. This one? Okay. So this platform which is there, right? So this is one of such platforms. Basically, it's crowdsourcing. In a sense, you're asking the public to do something for you. Yeah. So you may have some task which needs to be completed. You go to Amazon. You say, you know what, I got something, and you have to tell or design what that task is. And then what Amazon is going to do is, they have they call them workers. It's very wrong, but basically it's a list of, or a group of people, and it's a lot of people. It's not a small amount, honestly. It's a, there were like case studies on this that it's like kind of slavery, but let's not go there. They made them like a few cents, that's kind of wrong, but anyways, the thing is that a lot of people are there, and you can actually ask Amazon to ask each of them to complete whatever task you have. Why is it that Sorry? So the reason why platforms like this also exist are, just think of now, some of you are thinking of computer vision, right? How much label data do you think is going to be there? You've got the entire world of images out there. How can you actually even think of labeling all of it? As a company, even Google can't do it. Which is why...
Those things they make us label, right?
Exactly. Which is why every time you have the CAPTCHA code coming in, right? They're actually making you do it for free. You are labeling that code and telling them, that image, and telling them whether the object is there or not. They actually paid money to buy that company, by the way. Google paid money to buy that company behind CAPTCHA.
So you anyhow tag classify, it doesn't make a difference.
Right?
If you classify the images wrongly.
It's more like it's validating. So it's not that you're the only person who's getting that image, right? Objective is there'll probably be a few thousand people, because now it's free. For them, in fact, for Google, when they're doing it, the website helps detect that it's a human, right? They want to know whether it's a human. Google wants to get labeled photos. So they're going to show it to a few hundreds or thousands of people, if not tens of thousands. And whatever is the average, if you're against what everyone else is saying, it'll say you're not a human. That's how Triton does it. Also other factors like how fast did you end up labeling it, or did you click wrongly even once, or did you take too much time to label it as well. That's where they are applying further machine learning on that part. So labeling and getting labeled data is a very big pain. That's why platforms like this exist. If you're not Google, you have to go to the public and you have to get data and labeled in some manner.
CAPTCHA has two intentions, not just the second. CAPTCHA has two intentions, isn't it?
It has more than two intentions. So this is pretty much what Mechanical Turk is about, right? But again, of course, you got to pay something, and setup is a pain, but you can definitely go ahead with it. So like crowdsourcing to get results. This is another one for like the machine learning itself. That how do you actually get feedback for validating and training your data or your model, right? You can actually be using it. So this is an example of Mechanical Turk. Any questions first on this part here? The user collaborative filtering or the item collaborative filtering? Anyone? So for the user item collaborative filtering, which was the complex one that we went through, honestly, there's not enough time for me to go through everything. I can give you links which help tell you how it happens and how you can practice and play with it. If you're interested, I would really recommend go and have a look at it. It's not something which companies tend to ignore if they have the capability of doing it. Capability is basically when you're able to do it, that's when the company has the capability to do it, right? So companies generally would love something like this. It's just that they don't even know it exists, right? And it's very, very powerful. Even as a baseline, being able to, why do I say it's very powerful? When the first, when I was saying for the insurance industry when we did it, right, the accuracy which we got was like only 25%. Okay? To be honest, that 25% is not small. But anyways, the point is, when you're gonna get a lot of hatred from your own bosses at times when you give bad results, but you gotta stand up for it because you've done the best you could with the data. Just because somebody else is saying that it can be done, and especially if they're a non-tech person, just put your foot down. I mean, of course, don't try to like lose your job, but no, it does come to some situations like that when you're working on projects like this. But the thing is that once you've done something, obviously if somebody says something can be improved or something, go back, have a look, try and see how it can be improved. But just because they're saying the accuracy is too low or something like that, don't listen to what your own business side of people are saying. If they are challenging you too much, you have to tell them, hey, you know what, this is the initial version. Why don't you try and test it out on a very small sample, or maybe you show it to the client itself or to the other stakeholders who are actually involved. See what's their reaction, see what's the results that they are expecting. Why do I say that? Because when we done it for the insurance industry itself, we're getting like 20% something, and my CEO was like, it's small firm, so like 140 people. He was like, this is horrible. I've read that it should be around 80% accuracy and stuff like that. I mean, it became really, really bad between him, me, and my boss, because my boss obviously sat and we ended up doing the entire thing, the project, 3 months, and I refused to allow anyone to modify the program itself. We went back eventually to the clients because you have to showcase the results and you don't have time, right? When the managing director of the firm heard the results, he quite literally almost fell off the chair because they had less than a single-digit accuracy in terms of re-engaging customers. So from single digit going all the way even up to like mid-20s or early 20s is a huge boost for them. And they actually ended up prototyping and productionizing it later. So you've got to start from somewhere. Once you know what the baseline and the benchmark already is, right, that's when you can say you're performing badly or worse. But if they don't have a baseline itself, which most companies is the case, how can you say it's going wrong? It's still better than what you're doing right now. And in case you have a baseline, yes, then you can say whether you're performing worse or better. But just because somebody is saying arbitrarily that, hey, you know what, it should be 100% or even 70% accuracy, forget it, not happening. Because you've ended up working on the data, you know what the problems were, and it's going to be a lot of complexity. I mean, it can get really, really complex working with this kind of projects. Simply because even pre-processing the data, first of all, is a huge pain. Putting it into formats and putting it onto computers like ours or even in the cloud and all to work is not very, very easy. Even after you've got the results, doing the post-processing of understanding which are the top results is a task in itself, and finally evaluating the entire thing. You need to be very clear on how to translate the statistical results like RMSE and all back into business terms. An RMSE of 1 or 2 or something, what does it evaluate to? If somebody asks you this question, probably throw water on them. It's an error rate, right? It's in reference to what the actual value is. If the RMSE of 1 with respect to say an average or a standard deviation of 2, if the standard deviation is 2 and the mean is around 4, an error rate of 1 is probably horrible, right? But if the average of your entire prediction is say 40 or 50 or something like that, and you got an RMSE of 1, you're pretty good, right? It's always in reference to a particular statistic. Keep that in mind. Additionally, when you're talking about recommendation systems, especially the advanced, like the ALS and the other ones like I spoke of, just using RMSE, not necessarily the best idea. There's another metric which is called as precision. We've covered it earlier broadly when we've spoken of in classification. Okay, so it's called as precision. The technical way that you would go about it is something like P at K. This is how you would think of it in recommenders. Basically, when you're recommending K items, what is the preciseness of your recommendation? Level of precision. If you recommended 5 items, how many of those 5 items did users end up purchasing? If you recommend 10 items or 3 items, how many items did people end up actually taking or engaging out of those 10 items? That is a much more realistic or much easier metric to work with as well as compared to something like RMSE. Right? And why do I mention something like this? So I actually have some stats, if you want basic ones. I mean, I know other companies who are even into NLP and all, when we're talking about recommendations, right? The accuracy is actually not going to be very, very good. So this is, I mean, a huge unicorn in Germany, okay, where they're into like language education, basically, okay, helping companies, helping people, B2C, learn other languages. So what is the content we should recommend to you, which is the course, so on and forth, right? They are actually using these kind of recommenders. So when they were doing a precision at, I think it was 5, they're recommending 5 products. The precision that they were getting was like, say, close to 20%. Actually, it was around 19 point something. This is just one benchmark. Thing is, most companies will never end up releasing this. Just giving you a heads up. They're most likely not going to be releasing this. Because this is the key part to how they're performing. From a very ground level perspective, this is the actual way of understanding how good is your recommendation engine. When you're recommending 5 products, when you're saying it's precision of 20%, it means out of 5 products that you're recommending, one of them is actually being purchased. That's pretty much like when you're saying that in Amazon, when they're saying it's a quarter, 1/4 to 1/3, right? So when you're saying P at 4, or P at 5, so that's like 25%. When they're saying quarter of the 1/4 to 1/3 people end up driving it, precision is more likely what you're looking at. And this is a metric which is used, even if you go through that Facebook link or others, right? I can actually give you more. Precision is pretty much what, it's not a very clear concept, no one ends up disclosing these things. Because there's more like your trademark or your trade secrets, not even trademarks, your trade secrets. That how are you going about evaluating it actually? So precision can be very, very powerful in this case. There are other metrics as well. These are very powerful. Any questions?
So now you get all these predictions. How do you tune it?
Okay, so how do you tune it? How do you think you're going to be tuning it? Mechanical Turk is just for evaluation, right? It's only, see, it's good to use different tools and to understand what they're for. But, sorry, you got to understand what they're for before you say stuff. If chances are the person on the other end of the table is a bit more technical, they probably will start not listening to you anymore. So, but having said that, when you're working in your own teams in your office, it's perfectly fine. If you don't know, the objective of working in a team is that they should be telling you what's going wrong as well, right? They should be updating you on things as well. That's how a team is supposed to function. But the reason I'm just saying is, if you throw it to business, they'll take that as holy grail and they'll go on. So be careful what's your audience. How will you understand how to improve it?
You can choose a number of features.
One is the number of features. Can you keep adding more and more and more features all the time? How do you choose which features to use? That's the question. Right? Also, what's the weight? Till now we're saying we've taken just these 3 features, right? If you take things like the time, right? What's the effect of time? What's the weight of the recency? There was a field called as recency or time, right? Timestamp. Technically, you can actually calculate the way, if you notice how the timestamp is. This is it's a timestamp, right? Can you actually read what the time is? Do you remember I earlier once said that timestamp, generally you can actually calculate what's the time from 1971st Jan all the way till today. This is the number of seconds of the timestamp from that given time. So using this, you can actually even calculate how recent was this event to today. I don't care how far back is it from 1970. I'm more interested in how far back did it happen from today, from the time I'm training my algorithm or I'm deploying it, right? So the recency is what you would be considering as well now. weighting it by that. Seeing what's the impact, how you're going to do that. So there are multiple things that you would actually have to start considering as well. Number of features, now you've got to decide which are the key features. Honestly, I'll be very upfront. Tuning recommendation systems is not, it's far more non-trivial or far more problematic than tuning the other algorithms. Okay, so this is where I'll say you'll have to read up a lot more on how others are doing it. When I say others are doing it, okay, so when I keep telling you all that you're going to read up on what others are doing, right? So recommendation, give me an industry.
Fast food.
Food delivery instead. So some ways out are, yeah, you should definitely try and first understand, even from your McKinsey's and your PCGs and all, what is the state of the art things which are happening out there. But that's from the business perspective, okay? To put into your presentation that, hey, you know what, this is what others are also saying, and this is why we should be doing it. But to actually understand the techniques or the concepts, right? McKinsey doesn't know shit, to be honest. They're not the ones who innovate. They're the ones who convince business that we can do it for you. The ones who innovate will be the ones who are writing the research papers in the companies, right? So there are going to be research papers in most cases which are going to be written. So, websites like Springer, IEEE, and the others, right? That's pretty much where you're going to find out articles and websites. Now, how do you actually know which article or which paper is good, right? You'll see something like a citation. Yeah. So you can see this 13 citations. 13 citations means there are 13 other papers which have been written till date, which have actually referenced this article or cited this article. The more the number of citations the article gets, right, it means the more powerful it is. Now, additionally, as a thing, so there's this, let me be very clear, you do not hear this here, but there's this link called as Sci-Hub. Okay? Most of the articles you're going to be referencing and trying to read, right, they're going to be locked behind paywalls. What you can just do is come here, find the URL or you figure out what it is. You just enter it out here, and basically you can get the free version. But
Serious?
yeah, pretty much.
For any paywall?
Most paywalls which are like research based.
Does it work on Medium?
Yeah.
You don't need it for Medium because it's not. So here you go. See, they're asking for a captcha, but at least it's in Russian, so it's fine. Here you go.
Oh.
You know what? This is like
You did not hear this from me. Okay, so when you get like paid research articles, you can come here. Unlikely you'll get business articles coming in out here, like actually from your Stanford and the others. Actually, Stanford's can still be shown maybe at times out here, but not your PCGs and the other folks. They will not tend to disclose these things here. But why am I mentioning it to you? Because you can actually get a lot of articles from here. And you can go ahead and download it as well. Here, if you download, print, whatever you want, you're good to go. If you start getting blocked on Medium, right? So there's this, at least for me, I do this one is that. So you come, there's this browser called as Epic.
You can just go incognito.
No, it doesn't. It still, so it does, but then it still tracks you actually sometimes. It's very weird, I don't know. So, yeah, if incognito works for you, it's perfectly fine. Else you can download other browsers like Epic or Brave or something. Actually, I like Epic because even when you're trying to book your flight tickets, right? This guy is like completely off the grid, right? So you can just download this, and it's pretty similar actually to. It's very similar because it's actually based off Chrome itself, the Chromium project. get like a VPN if you want. Right? And I mean, we didn't. The fuck. So I mean, you can definitely be going to using Epic to even like at times book your flight tickets and stuff, and you're good to go with that. Right? So quite a few times when I have to check out my own website at times, right? So I end up going via via that Epic itself to try and determine how it actually looks on a completely untracked kind of system, or other websites to see what's the thing behind a completely untracked thing. So Epic is pretty good for that. Like your Skyscanner and the others, because quite a few times when you're using it on your own laptops, right, even incognito, it starts jumping up the prices like crazy. Epic still kind of gets away well with that, but the problem is you can't completely book your flight tickets out there because the other sites don't work well with it. Right? So these are some ways how you can actually go ahead and start looking into content. But now if you want, yeah, so I was saying, no. Actually not food delivery is the wrong one. Recommendation system, retail. So even if you start from Google Scholar, right? Hey, it should be telling me now. You just simply go to Google Scholar instead. So once you go to Google Scholar, right, this is actually Google's way of is it Google Scholar? Oh, why am I saying recommendation? So stupid. Don't give it terms like recommendation systems and the others. Actually call it the correct terminology, which is collaborative filtering. There you go. That's why. There's no, if you're actually a technical person, you're not going to be calling it recommendation. You're going to go with the algorithm name itself. So the moment you do that, right, you can actually start picking up a lot more based on the actual thing you're looking into. So say you've come to Google Scholar, right? Here, now based on this, you can actually start picking up things like, if, first of all, citations are very important, all right? Understanding how many people is this article or this document actually cited by. Another thing is, when was the document actually written? If it's written in 2005 or 2000s or 1990s, hey, we're like 30 years or 20 years later. It doesn't probably even impact you. Most of the times, okay? Try and stick like within this decade or late last decade. Try not to go beyond that, because then people may not believe in it too much, right? Things have changed a lot. Additionally, you can just click out here. If you click out here on the PDF, right? If there's a link and you click on this, it'll actually open up the document itself for you. Even if it's a paywall one, if it's got the link, open source, it'll actually open it for you. Okay? This is pretty much how you start with your research side of things. It may sound like as if I'm telling you how to do a lot, but you would need to do it at some point, honestly. If you need to understand more about, so like how Ziyachi you mentioned, if you want to understand how to tune or improve things, right, you've got to go through what others are doing, quite literally, in the field. So, intelligent food planning, other things as well. Recommending locations and services via geospatial collaborative filtering, based on your location and based on how it's happening. I mean, it's going ahead. It's been cited, of course, it's a patent as well, but it's been cited by 173 people. Those are the kind of things that would actually be quite interesting to you. Personalized recipe recommendation. Crazy. So, I mean, it's across the place. You're going to have to see which one is relevant to you, your industry, and your use case. That's how you start out. Okay, so now your question specifically was, say you given the keywords you're looking into, or choose the industry. Say for me it was loyalty. So it's saying that there were 10 people who went with this document. On the other hand, this is just a survey of collaborative filtering techniques. Maybe it might be important for me, based on what I'm reading here. Collaborative filtering or regression models, whatever, it's up to me. So you're gonna have to go through a lot of actually articles to try and start understanding more about which ones would be relevant to you. This is what happens on the research side initially of projects. How do you choose which algorithms? How do you choose what's the latest things? How do you try and build those out for your own company? This is how you can get started. See, if you're not sure about how to do things, it's fine. To be honest, most of us are not. We're just trying to do things. The more you'll fail at doing it, it's fine. As long as you have just any job which is in data, which is helping you get by, right, initially, you just keep experimenting from there, and then you move on. You don't have to do everything at once. Small wins, that's how you're going to do it. Start giving them something small, they'll believe in you more. Then you start going into more advanced things like going through the research papers and telling them what's happening as well. What's state of the art, or what's cutting edge technology, or bleeding edge, so on and forth. Right? Start initially with Medium and other places where people are even talking about the actual use case, what's the business problem they solved, and the code. Just doing that initially is a very big thing in itself. Once from there, then you move on into picking up your own projects, understanding what's new, what's actually happening, and then you build on things from there. All right. Any questions on this part? Any questions? That's pretty much it then for today, I guess. So next week, I believe you all will be Vikyang is going to be coming in as well, and he's been actually doing DSI since even before, since probably around the time I started working in Singapore. So he's definitely much more experienced as well in this. Don't worry. Any questions at all? Spam him. Don't worry. Ask him everything that you can think of as well. Even your capstone projects, right? If not during the class, Slack him as well. He will also be happy to help out. If not, try and Slack me. I'll try and get back at the earliest, but no guarantee immediately, obviously. Yeah, that's pretty much it. Right? Any questions? Anything? You think you need? Do try and keep thinking of, your capstone projects as well. Try not to work in Christmas break as such. Try and do how much of you can, like by this or next week itself. Take some time off. You're going to need it for sure. Take some time off. Yeah. I can give you links and articles because the thing is.
It's not necessary. Do we have the starter code for it?
So I gave you. I did not send that code. That link which I sent you all, right? Even if you use that entire article code. Even if you use the code from this link itself, right? You start trying to implement it. You'll get a good hang of it. Alternatively, let me send you this. So it's slacked it over you all as well. Additionally, use AMS. Insert library. I mean, even if you all go ahead and implement that link which I sent you all, right, it should be much more than enough. And again, this person seems to just copy the code which the other guy said. But yeah, this is the same thing. This is the research. I won't give that out to you. Does it make sense? So the main thing you'll have to keep in mind, right, is that the pre-processing, getting the data from your raw form, wherever you have it, right, into the structure for this matrix, where it's actually got the pivot table kind of a concept, right? That part is going to be kind of unique to each and every problem you do, because the data, the raw data might be in different forms, right? Each problem that you try to solve it for, this raw data will be very diverse. Putting it into the into this matrix, sparse matrix as well, right, is where a lot of the effort is initially going to go into. So that's what even this one is saying. I'll send you all this link. So creating the data is one step, or one major step in itself, okay? Once that is done, building on the sparse matrix, that's pretty simple. And then you can just be applying, okay, this seems a good one as well. So this link which I just slacked you right now beneath the Benfred implicit one from GitHub, this link, this actually helps show how you're going to be using the implicit library itself. Right? Go ahead, use this one. You're perfectly fine using this. The objective is not to get drowned in the mathematics of how it's happening. First, understand what has happened, then you go towards the math to try and figure everything out. Okay? Implement this, get an understanding of how to evaluate and to use the model. Okay? He's not talking about the evaluation as such right now, but that part is something you can look into as well. So does this give an overview of how you can try and implement? This is a direct implementation. If you notice, it's using implicit.als.alternating least squares, right? This is the initial thing. As a heads up, I'll say that library is very powerful because you can do a lot more things than just directly implementing the ALS itself. I'll tell you what in a few minutes. Just see. On the other hand, this one actually walks you through how to go about the entire process at a line by line level. So if you want, this can actually help you understand the concepts behind all of it, right? So it might be quite useful as well. But you gotta figure out what's happening as well in some situations, like this one, making the training model, right? You're basically creating a test set, sort of forth, and actually implementing the final thing. Yeah. Okay, so this seems to have become the de facto standard since But the good thing of this is actually looking into how you'll be evaluating it. Yeah, this is a good example as well how you can go about it, right? So you can use this block. I know it's a lot of stuff just throwing it, but you're gonna have to play around with these things if you're interested in this approach or this technique. You have to get your hands dirty. You have to play with it. No two ways around it. Okay. Just as last note, what I'm going to say. So that algorithm, that approach which is there, is kind of using this data set. That's what they're saying. It is a very powerful concept, which is again, it may sound like I'm harping on it, but it's actually being leveraged in a lot of companies, a lot of industries. You can actually change. This is one retail data set which is there, right? It's from UCI machine learning, which is being used for that project. Okay. Now, once you understand the concept and how to apply it, right, you can actually go and apply it in multiple cases, multiple situations. So, why am I saying that? Because there are a lot more data sets which are similar to this one. If you are interested in retail kind of transactions and to implement things again, right, you can actually go to data set, Instacart. Although Instacart is a bit more bigger as well as problematic. So their data which is there. So they have different data sets out here. Why is it signing? Right, there you go. So this is the description of each file which is there and everything beyond it. So it's a pretty big case of what happened. Anyways, what's only 200 MB? Okay, but this should be around like 2 to 3 million records of transactions, right? So not small data set either, but can definitely get started with it if you want. This is a bit more advanced than the one that you're probably looking into. Yeah, like it says 3 million Instacart orders, which have been like released to the public. That hey, go ahead, have a blast, play around with it. You can actually start trying to see how you can do ALS on these kind of projects as well, right? To get started. One thing I'll just mention is once you're done, say with doing your ALS, right? What does ALS finally give you? The end of the ALS, you get this matrix, right? Which is just telling you likelihood of each product for each user. That's all that it does. Does it tell you what rank you should be showing the products to? What rank you should be showing each user the products in? We are actually doing the sorting ourselves and we are picking it up like that, right? So building on top of ALS, right, there is, just giving you all the information. I hope. Are you all still fine? Still surviving? Okay, so one step on top of this form of recommendation systems, right, is something what you would call as ranking. What rank are you going to assign to each product now? Even after you know how likely is one person going to engage that product, right? The rank in which you're going to show the products can be different. Okay? A lot of different approaches, so on and forth, which are there. One which has been growing since a while is called as BPR, Bayesian Personalized Ranking. It's there in this implicit data set as well. Bayesian Personalized Ranking. Okay, and there are other approaches, of course, and all like factorization machines as well, but those are more even state of the art, if not this one. But the problem that comes with using more and more advanced concepts, right, is one fact that it gets much tougher to explain and to evaluate, right? Secondly, they're still being tested and run in multiple companies, which means that it's still not 100% stable enough yet. Okay, but they're still being used quite a bit for ranking. Just trying to tell you that on top of personalization or product recommendation or item recommendation to each user, you have a concept which is called as ranking, which involves how will you showcase the products to each user. The ordering, basically the ordering. Once you know which products are also there, just by looking at the similarity score, is actually not enough still. So you have to, this is like, how do you tune or improve the recommendations, right? This is more of a way how to go about doing that. Rather than just throwing more and more variables from the existing set of data itself, how can you even rank the given information? That's important. One more thing I'll say is, which can actually influence and majorly impact. What do you think is something which can majorly impact the way your recommendations can work? How are you showcasing the results? Who are you showcasing the results to in the first case? After you do all of this, what's going to happen? What do you think is going to happen after you do this? It's just going to go and sit in a database, that's all. Your results from that matrix and everything, right? So you've got an entire result of all the end users and end products, right? Now, next step would be the way actually that you would go about doing this entire project, right? It's like this, or projects like this. The first step is actually get the data, obviously, right? Even getting data at times can be very problematic. Once you've got the data, there's a lot of pre-processing which is involved, so that it can go into this stage, right? So the pre-processing. The pre-processing of the data. Maybe you need to cleanse it, maybe you need to scale it, normalize it, figure out problems in the data itself. A lot of things happening out there. That's when you'll come up with, see, the third stage is actually building out this initial preference or the initial say this is the recommendation algorithm, right? Let's just call it the algorithm itself, the core black box under which you're doing everything, right? Once you've done this part out here, okay. So once you're done with this, right? Honestly, oh sorry. So I'm going to switch this off. This is pretty much it for this right now. Now, after this, you want to find out what are the top products for the users, right? So it's going to be M cross K, where K equals top K products or items. Top K items for M users. Alright? Each user, which are the top items. This result which is there is actually going to be stored more into a database. Because you can't keep training or running your model, it's going to be very computationally expensive, right? You can't keep running this in real time. No ways. No ways can even on Amazon do it today in real time. Not happening. So you store the results into a database and the software team picks it up from there. That's the end of pretty much your job then. After you saw the results, the way I'm like just walking you through the entire life cycle of this kind of a thing. This is where software has their front end which is there. The front end that you actually see on Amazon.com, anything at all, right? The moment you've logged in, or the moment you've not logged in, irrespective. Actually, both scenarios will have different outcomes. Remember, we saw unaware, aware, and all the other things. Unaware, all these are also things which you may have logged in, you may not have logged in. The moment you log into a website, it changes the layout, right? It changes it. So, the moment you log in, it gives you things like your user ID, right? Your location, things like that, so on and forth. Those are the inputs that the system takes from you. Once that is done, it provides us input maybe to the database, and the database is going to return the results from here. That for this user ID, which are the top K products, we need to show back to the user. So that at the end of the day, you may possibly have a carousel which will actually show it all to you. Alright? Which means everything you've done till here is useless if you don't showcase the results out nicely. If they screw up the UI, oh man, you're dead. all your recommendations and all those months of hard work, right, all down the drain. So you better be good to the UI people and ensure that there's a lot of nice ways of presenting this information. Why do I mention that? When you go to Google as well, right, they don't say this is recommended for you. We're suggesting this article. I mean, they don't kind of force their recommendations or suggestions onto you. They have, the way you phrase the entire concept as well. People who purchase this also purchase this. Items similar to this. The way you articulate it as well, right, can make a world of difference into how the end users will end up consuming that information. It should not sound like as if you're forcing it, or it should not sound like as if you've already made the decision for them. The moment anyone implicitly, it's like psychology as well, they're probably going to be like, hey, this is a bit negative. So that's all part of the A/B testing as well, okay? Where you've got to figure those things out and understand how things are happening. And of course, once that's done, we finally productionize it as well. Coming back here. So this is more of a broad life cycle, how you can go about doing it. Starting from the data, of course, when you're getting the data, it can again be from a database itself, or from CSV, so on, depending on company stuff. Prepare or pre-process your data. You put it through your DIA algorithm, which is you put it into the format, let the engine run, you'll get the results. Once you've got the results, you've got to prepare and find out the top K items for each user. That, most likely, is always going to sit into a database. With software, is always going to be touching in real time. Because the front end will communicate with the database, it'll give user input, it's already defined by the APIs. Remember we had Flask and everything else, right? So the Flask server, suppose that's the server which is there, right? The Flask server is just going to be running an API. I mean, it has the APIs already built, the endpoints. So whenever the user loads the page, for this part alone, only for the carousel, there'll be one link which is, or one URL which is called immediately, or one endpoint which is activated. It gives that information, comes back with the results, and it's showcased out here. So this is where all the things, or the bulk of the things that we've been learning, right, actually start coming back. Whether it's object-oriented programming, servers, the actual ML itself, right? Any questions on this part? Sorry if I'm overloading you with too much information, but it's just that this is realistically how it happens. So just to give you again a slight heads up, the core ML engine which you're going to build, right, is almost always going to be only 20% of something of your overall project. The actual machine learning, the rest of their time is actually going to be in pre-processing the data, post-processing the data, and getting the results and pushing it all out. Convincing others as well that, hey, you know what, this is good. We should be working on it. We should now move to the next phase, which is A/B testing. After A/B testing, maybe productionizing may not necessarily be data science itself. That might be more of data engineers as well, or software engineering itself, where they look at scaling things up. So the bulk of your time is always going to be on working with the data, not the machine learning itself, because the algorithms are already predefined, right? It's how do you actually use that to tune or fit your data better. That's the core part which you may use more of ML in. Cool, sounds good. So if any questions at all, do slap me, and I think I'll see you all. Any questions at all? All good.
So you won't be around next week, right?
No.
So that means you won't be. Will you still be answering Slack?
On and off. On and off. How much is on? I can't say right now. I will try and answer it preferably at like night time.